Hello everyone, we are again back with another video. I am Salman Ibn Yunus from the AI Educator. So in this video we will take a look at some of the basic concepts of PyTorch, like some basic calculations. After this video we will move into computer vision and deep learning and neural network architectures with PyTorch. So before we see those deep learning and neural network using PyTorch, we must learn some basic concepts and calculations using PyTorch and how to use the library for some basic functions. So first of all, we must know that since we are using Google Colab, there is no need for installations, because in Google Colab PyTorch is already pre-installed, so this makes the process more convenient. So first of all, as usual for every library you will have to import PyTorch. So for importing PyTorch you will have to write import torch. So if you run this cell, we will see that it works. Then we'll have to use torch.version dot underscore version. This line we will write this line to if you want to see the version of the PyTorch. So this is 1.10 version, so it's one of the latest versions. So then we can take a look at what we can do, what are the basic calculations we can do using PyTorch. So PyTorch is, as I have already said, is quite similar to NumPy. So if you are familiar with NumPy, you will be able to relate with me. So first of all, as we have said, that PyTorch uses torch or tensors, which is a multi-dimensional array like NumPy arrays. So we can use torch or tensor to create some arrays or some matrices, some multi-dimensional arrays. So if you see this line of codes, so we are taking a variable a with torch.ones 3, 3. So what does this mean? The 3, 3 means that there will be a matrix with 3 rows and 3 columns, just like NumPy. And torch.ones means all the element of the matrix will consist of only 1. So as you can see, if I print this, I have printed this cell already, so you can see that there are 3 rows and 3 columns and all the elements are 1, since we are using this built-in function of PyTorch. So this is torch.1. So similarly we can create another array or tensor, that is using torch.0. So similarly here there is 3 rows and 3 columns, but since we are using torch.zeros method, so it will create all the element with zeros. There is also another built-in function of PyTorch, that is torch.I. So there again we are using 3 into 3 rows, 3 columns. So what does torch.I does? So torch.I actually creates an identity matrix, that is, it creates a 3 by 3 identity matrix. So as you can see, that identity matrix has 1 in its diagonal. So also we can perform basic addition, subtraction using PyTorch. So we have added here a plus c, and as we can see that a and c are added. So in the places where there was 0, since 1 was added, so you can see that here this is 1, and also there are places 1 plus 1 became 2. So since we have added the a matrix and the c, that is the identity matrix. So this is like a simple matrix addition, if you are familiar with matrix addition, matrices. So also we can carry out matrix multiplication with a times c. So we know that if we multiply any matrix with the identity matrix, what happens? We should, in our elementary studies or in our college days, we must have studied that if you multiply anything with identity matrix, we get the identity matrix. So as you see that we are getting the identity matrix here. Also we can So these are like some fixed multidimensional arrays we have created, like using only ones and zeros as the element. So we can also create our own custom array just like NumPy. So we'll have to use this function torch.tensor, and inside this function we'll have to put a list of the rows and columns, list of the elements which will be contained in the rows and columns. So this is a list structure if you know the data structure in NumPy or Python. So actually adding more list actually increases the row, and adding more elements actually increases the column. So if I for example, if I add here 4 and here also another element and here also another element, so this will increase the column size. So as you can see, a new column has been added, 4 2 2. And if we like add another element or list of elements, for example it was like some random numbers, so this will add another row. So as you can see, a new row and a new column has been added. So you can, in this way you can add a new row and column for your custom tensor or multidimensional array. So tensor is a multidimensional array just like we create using NumPy arrays. So we can use this a1.shape function to see the shape. So you have now 4 rows and 4 columns. So we can also carry out division using PyTorch. So a1, simply a1 divided by a gives us the division. So here you'll have to make sure that the size of the tensors both of the tensors should be same. So here, since a1 is actually has a bigger size, so here it is showing an error. So if we change the, actually a1 has a bigger size and a has a smaller size. So if we change the size of a, like if we make it 4 and 4, then we will be able to divide. So now we should be able to divide, because so yeah, you can see that a1 and a has been divided. So also we can subtract. So here this is the subtraction of matrix, and then we have taken another variable called b1. So b1 actually has a function called torch.rand. So what does torch.rand do? So the .rand function actually creates random numbers between 0 and 1 with 2 rows and 2 columns. So there are 2 rows and 2 columns, and it creates some random elements for this array. For this tensor, it creates some random values between 0 and 1. So this is the function of torch.rand. Also there is another function in torch called mathmul. So what does mathmul or what does this function do? So it actually does multiplication, but this is not the matrix multiplication that we generally do. This is dot matrix multiplication or element wise multiplication. So here probably again, since we have changed the sizes, so it's not working. So we'll have to actually change the size of C as well to carry out this dot matrix or element wise multiplication. So as you can see that C has 3:3. So if we make it 4:4, so then we should be able to multiply it, or we should be able to carry out dot matrix multiplication. Oh, so here there is a syntax problem. So now this should work. Yeah, as you can see, it has done a dot matrix multiplication with A and C. So actually this is the end of our video. In the next video we will learn about neural networks and how to code neural networks and how to use pre-trained neural networks using PyTorch. Thank you all for your time, patience and understanding. Goodbye. See you in the next video.